In this video, I want to introduce you to the idea of inverse functions. Most functions have an inverse function, and what it is a mirror image over this line. This line is called y equals x, and so we're looking for a function who is a mirror image of another function. So, for example, I'll start with a linear, nice and easy. F of x equals 2x plus 4. We know if we graph that, we would start at 1, 2, 3, 4. And we would go up 2 over 1, or down 2 over 1, down 2 over 1, so it would look like this. And so what we do in order to find an inverse function, the steps are as follows. You switch, let's use y for this for now, y equals 2x plus 4. You switch the place of the x and the y, so x equals 2y plus 4, and then solve for y. Try to get y by itself. So subtract 4 from both sides. You get x minus 4 equals 2y, and then divide everything by 2. And now you have y by itself. Y equals, I can write this as 1/2 x minus 2. 4 divided by 2 is 2. This is the inverse function of this. And the notation for inverse function, as I wrote up here, instead of calling it f of x, we would write it like this. And it shows me that this is the inverse function of this function up here. So if I were to graph this, I would start at -2. My slope is up 1 over 2, up 1 over 2. So it looks like this when you graph it. And it's the mirror image reflected over this line y equals x. And so what it means also is that the domain of one is the range of the other. So in other words, if I was to plug in, for example, a 2 right here, so let's make a little table here. I'll plug in a few values. If I plug in 2, 2 times 2 is 4, plus 4 is 8. I get the solution 2, 8. If I was to plug in 3, 3 times 2 is 6, plus 4 is 10. So I get 3, 10. So in this table here, if I was to make a table of solutions, if I were to plug in the opposite here, I'm going to plug in the range that I used here. And if I was to plug in 8, half of 8 is 4, and 4 minus 2 is 2. So I get this answer here. If I were to plug in 10, half of 10 is 5, minus 2 is 3. So what happens is the domain of this function is the range of this function, and vice versa. The range of this function is the domain of this function. So they're sort of like opposite inputs and outputs, and so you get this mirror image. One of them has the solution over 2 up 8. The other one has the solution over 8 down 2, or up 2 rather. So again, they're mirror images, and they're called inverse functions, and this is the notation. So that's what I wanted to show you in this video. That's a linear function. I'll show you now using a quadratic function. So we'll start with one that we know, y equals x squared. It's a very basic quadratic function. Let me draw this line again. This is y equals x cutting through the center. So it'll be the mirror image over this. Again, in order to, so I'll write this also as f of x equals x squared, same thing. If I switch the x and the y, and I say x equals y squared, so the steps are always, to find the inverse function, you switch the x and the y, and then solve for y and try and get y by itself. So to try to get this y alone, I would take the square root of both sides. The square root and the square would cancel each other out, and I would just get y equals the square root of x, or y equals the square root of x. And that's the inverse function, so f, I'm using this notation, f -1 of x equals square root of x. So this is the inverse function of this. And we know that the graph of y equals x squared is a parabola. So it looks like this. But what we haven't seen yet is the graph of this. So if you were to plug in, let's say, let's make a little table here. If you were to plug in 4, let's say, which is a perfect square, the square root of 4 is 2 and negative 2. So if you were to plug in 4, you would get 2 and negative 2. If you were to plug in 9, you would get 3 and negative 3. So if you went over to 9, 3 and negative 3. And of course, if you plugged in 0, you would get 0. So it looks like this, sort of a sideways parabola. And it's the mirror image of this graph reflected over this line, y equals x. And so these solutions are just, if you were to make a table for the original one, if you were to plug in 3 and you square it, you get 9. If you plug in negative 3 and you square it, you get 9 also. So you can see that the inputs here that are producing these outputs is just the opposite here. So the domain of this function is the range of this one, and the range of this one is the domain of this one. And that's an inverse function. So most functions have an inverse function. I guess I should mention that technically speaking, this is not what we consider in mathematics a function. It's more called a relation than a function, because functions have a one-to-one correspondence. You plug in a number, you get out a number. But here, when you plug in a number, you get out two different numbers. So it's something called a vertical line test, where when you draw a vertical line, if it cuts through your graph more than once, that means you have two solutions. It's technically not a function, it's a relation. But for our purposes, we're going to call it the inverse function. If you wanted to, you could just count, the square root of 9 as just being 3, and you could just show this side of the graph here. We're going to call it an inverse function just so I can show you that each function can have something where you plug in the inputs and you get out the outputs, and then the vice versa happens on the other one. I think I'll stop there. I just wanted to show you what an inverse function is, so that's it.